Now we think a little bit about maxima and minima. For example, a function like this, a point where there's a relative maximum or a point where there's a relative minimum, if we drew the tangent line there, we'd have a horizontal tangent line. And that's one kind of max or minimum. But of course there are other functions, for example the absolute value function, where the point where it comes to a minimum, the derivatives does not even exist. Absolute value function is not differentiable at 0. And so there's two kinds of maxes and mins. One where you get a slope of 0, and one where you have some kind of point and you just can't take a derivative. This leads us to the idea of a critical point. A critical point of f of x is a point where one of two things happens, where either f prime of x equals 0, or b, the derivative does not exist. And so either one of those makes it a critical point, having a derivative equal to 0 or a derivative that does not exist. And it's very important because all extrema occur at critical points. It is impossible to have a maximum or a minimum of a function except at a critical point. And notice, incidentally, doesn't work the other way around. It is possible to have critical points that are not max and minimum. So, for example, y equals x cubed, that's a function that has a horizontal slope at the origin, but of course that is not a max or a min. The function is increasing, then it gets horizontal, then it goes on increasing again. So that's a critical point where there is no extrema. You also get with y equals cube root of x, you get a vertical tangent line. So at that point at the origin, the derivative does not exist because the function becomes momentarily vertical. But again, function increasing becomes vertical and then keeps on increasing. And so that's not a max or min either. So the idea of an extrema, if it's an extrema, it has to be a critical point. But if it's a critical point, it's not necessarily an extrema. That's an important distinction to keep in mind.